Okay, so in this section, we're going to talk about the greatest common factor, sometimes denoted as GCF. And before we do that, let's just talk about some terminologies related to GCF. Okay, so we all know that 3 times 4 is 12. And 3 and 4 are called factors. So notice the word factors of 12. And they're factors of 12 because 3 goes into 12 evenly and 4 goes into 12 evenly, meaning you get a remainder of 0. Some other, and also 3 times 4 is a factored, notice the word a, is a factored form of 12. So in this chapter, you're going to be writing factored forms of polynomials. So the same idea applies with integers and polynomials, the idea of factored form. So you want a product. Another factored form of 12 would be 6 and 2. So 6 times 2 is also 12. And so 6 and 2 are called factors of 12. And also 6 times 2 is a factored form of 12. Okay, so when we begin this chapter, you're going to be factoring polynomials. So for example, you'll be factoring something like x squared plus 5x plus 6. Now that's an easy example to factor. It's one of the easiest ones. But this is how it's going to look. So remember how here 3 times 4 is a factored form of 12. So two numbers or two factors whose product is 12. So when you factor this trinomial, you'll be looking for two factors whose product gives you this. And so you're going to learn that the answer is x plus 2 times x plus 3. And so x plus 2 is a factor of x squared plus 5x plus 6. And so is x plus 3 is also a factor of x squared plus 5x plus 6. So the idea of factoring trinomials in this section, or factoring polynomials, will have this idea. So find some factors whose product is this polynomial. Now we're also going to talk about the fact in this chapter that you want to factor completely, meaning that this factor here, there's nothing else you can factor out. This factor here, there's nothing else you can factor out. Okay, so that's going to be the idea behind this section. Now let's talk about finding the GCF of a list of numbers. So finding the GCF of a list of numbers. So the greatest common factor of a list of integers, the greatest common factor of a list of integers is the largest integer that is a factor of all of the integers in the list. So the largest integers, here's the word greatest, and then the idea of common. So the largest integer that is a factor of all of the integers in the list. So for example, suppose I wanted to find the GCF of 12 and 20. All right, you want to find the GCF of 12 and 20. All right, so it turns out that the GCF, so the answer is 4. Is 4 because 4 is the largest integer, that is a factor of 12 and 20. So it's 4 because 4 is the largest integer that is a factor of 12 and 20. So one approach to get this, is to list all factors, is to list all factors. So for example, factors of 12 are 1, because 1 goes into 12, and what you could do is say 1 times what is 12. So the other factor is 12. So 1 and 12 are factors of 12. 2 and 6 are factors of 12 because 2 goes into 12 evenly and 6 goes into 12 evenly. 3 and 4 are factors of 12 because 3 goes into 12 evenly and 4 goes into 12 evenly. So those are the only factors of 12. So if you look at 20, factors of 20 are 1 and 20. So 1 and 20. So 1 goes into 20 evenly, 20 goes into 20 evenly, meaning you get a remainder of 0. 2 and 10. 2 goes into 20 evenly, 10 goes into 20 evenly. 3 does not a factor of 20. 4 is a factor of 20, so 4 and 5 are factors of 20. So 4 goes into 5 evenly, 5 goes into 5 evenly. 6 is not a factor of 20, 7 is not a factor of 20, 8 is not a factor of 20, and we already dealt with 10. And really all you got to do is just go halfway. So half of 20 is 10, so just check the factors up to 10. Okay, over here, half of 12 is 6, so just check up to 6. All right, so those are the only factors of 20. So if you look at the common factors, so your common factors are 1, 2, and 4. Those are the only common factors, so 1, 2, and 4. What you want is the greatest common factor. So the greatest common factor is 4. So the GCF of 12 and 20 is 4. All right, so that's one approach to finding the GCF of lists of numbers, is to list the factors of each one and then find the one that's the largest common factor, the greatest common factor. Okay, now another approach is to use what's called the factor tree, and you did this in a previous course. So let's find the factors, or rather the GCF. Let's find the GCF using a factor tree. All right, so basically you would write 12 as a product of prime numbers. Okay, so the idea is to write 12 and 20 as a product of prime numbers. Okay, so that will be another approach. So 12 we know is 6 times 2. 2 is prime. So I'm going to circle it just to remind me that I'm done with this branch of the tree. 6 is not prime. 6 is composite. So that means I can factor it further. So that's 3 times 2. So 3 is prime, 2 is prime, and I'm done with 12. So 12 is 2 times 2 times 3. 2 times 2 times 3. So that's 12. 2 times 2 is 4. 4 times 2 is 3. And always make sure that these factors, all the factors listed, are prime. So 2, 2, and 3. They're prime numbers. Okay? Now, for 20, do the same thing. For 20, I can say 4 times 5 is 20. You could have said 10 times 2. It does not matter. Just find two numbers whose product is 12, find two numbers whose product is 20, and then go from there. 5 is prime, so I'm going to go ahead and circle it. 4 is not prime, 4 is composite, but I do know that 4 is 2 times 2, and those are prime. And so I'm going to rewrite 20 as 2 times 2 times 5. So 2 times 2 times 5. All right, so I'm trying to align any like factors. You didn't have to do that, but it sometimes helps. Okay, now look at all the factors listed. You want to look for the common ones. So in 12 and 20, we have these sets of 2's that are in common. We have these sets of 2's that are in common. There are no 3's in common. There's a 3 here, but no 3 here as a factor. There's a 5 as a factor for 20, but none for 12. So the greatest common factor of 12 and 20 would be 2 times 2, which is 4. Okay, so that's one approach to take. All right, let's look at another example. Let's look at 28 and 40. 28 and 40. And we're going to use a factor tree. So 28 and 40. So find the GCF of 28 and 40. Now, most of you probably can look at that and say what the answer is. But if you can't, then just go ahead and do the factor tree. All right, so 28 is 7 times 4. 7 is prime, so I'm going to go ahead and circle it. 4 is 2 times 2, and those are primes. So 28 is 2 times 2 times 7. 40 is 10 times 4. Those are both composites, so I can go further with it. 10 is 5 times 2. So I'm going to circle those because those are both primes. And then 4 is 2 times 2, and I can circle those because those are both primes, and I'm done. So 40 is 2 times 2 times 2 times 5. Okay? All right, so again, we're going to look for the common factors. So 20 and 40 have this set of 2's as a common factor. They have these set of 2's as a common factor. And here's an extra 2 for 40 as a factor, but it doesn't occur. I don't get an extra 2 as a factor for 28. So I can't circle that one. I'm only looking for common factors. 7 is a factor of 28, but it's not a common factor of 40, and so same thing with the 5. So in terms of the GCF then, I'm going to get 2 times this 2, which is 4. So the GCF of 28 and 40 is, oops, so the GCF of 28 and 40 is 4. All right, let's look at one more. Let's see. So let's do. All right, let's find the GCF of 48 and 72. 48 and 72. Let's find the GCF of 48 and 72. So we're going to use a factor tree again. So 48 is 8 times 6. You could have chosen any two numbers. It does not matter. You could have said 24 times 2 if you wanted to. Does not matter. These are both composites. I can go further. 8 is 4 times 2. This 2 is prime, so I'm going to circle it. 4 is 2 times 2. So that takes care of that one. 6 here is 3 times 2. All right, so I'm going to get 48. 48 is, all right, let's start with the 2's. 1, 2, 3, 4 is half. I have 2 times 2 times 2 times 2. And then times 3. So that's a prime factorization for 48. So 2 times 2 times 2 times 2 times 3 is 48. 1, 2, 3, 4, 5. Make sure you have those 5 listed. All right, let's do 72. 72 is 36 times 2. 2 is prime. 36 is 6 times 6. 6 is 3 times 2. Those are both primes. I'm going to go ahead and circle it. 6 is 3 times 2. Both primes. I'm going to circle it. So 72 is, all right, I have 3 2's. So 2 times 2 times 2 and then 2 3s, 3 times 3, and that's it. All right, so 72, the prime factorization is 2 times 2 times 2 times 2 times 3. So remember, prime factorization is where you rewrite the composite number as a product of prime numbers. All right, so then we just look for common factors. So common factor is this set of 2's. Another common factor is this 2. Another common factor is this 2. I can't do anything with this because it doesn't occur again, but 3's are common. And that's it. I can't circle this one. All right, so notice common factors, what they have in common. So then the GCF would be this 2 times this 2 times this 2 times this 3. All right, so then I'm going to get, let's see. All right, so then I'm going to get 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So the GCF is 24. So the GCF of 48 and 72 is 24. Okay. All right. Let's do one where we have 3 numbers, because on my math lab there is an example with 3 numbers. So let's find the GCF of, and let's see. Let me see which one I'm going to use. Okay, so let's do this one. Find the GCF of 42, 28, and 56. So 42, 28, and 56. Again, let's just go ahead and use a factor tree this time. So we're going to rewrite 42 as 2 times 21. You could have said 7 times 6. It does not matter. 21 is 7 times 3. And all these are now prime. So I'm done. That's a 7. So I'm done with 42. So 42 is 2. I'm going to go ahead and just wait to write these because I'm going to try and align common factors to help me. So let's go into the 28. So 28 is 7 times 4. 7 is prime. 4 is 2 times 2. All right. And then 56 is 2 times 28. 2 is prime. 28 is 7 times 4. 7 is prime. And 48 is 2 times 2. All right, so I have 1, 2 here, 2 here, and 3 here. So let's go ahead and do this. Oops, 28. It didn't matter if I put 56 next. All right, so 56 I know is 2 times 2 times 2. 28 is 2 times 2. I have a 3 and a 7 here. I have a 7 and I have a 7. So let's just do times 3 times 7. I need this 7 here, and I need this 7 here. So I just try to line them, but just make sure what you have is correct. So 42 is 2 times 3 times 7. 28 is 2 times 2 times 7. And then 56 is 2 times 2 times 2 times 7. All right, so then we're going to look at our common factors. Our common factors for all 3. So all 3, this set of 2's is common. I cannot circle another set of 2's because this one doesn't have an extra 2 as a factor. And then 3, all 3 numbers do not have 3's as factors, but they do have 7 as factors. So I'm going to go ahead and circle this one. And that's about it. That's all the common prime factors that they have. So then the GCF is this 2 times this 7, which is 14. So the GCF of 42, 28, and 56 is 14. Okay? All right, so that should take care of this idea. So that's the end of that one.